today's lesson in section 7.4, talking about basic trigonometric equations. And so basically all we're doing is solving equations, but you're just involving trig functions. Now there's two ways of solving them, or like two kind of or answers that we're going to get. So you either have to solve your equations over all real numbers or in a defined interval, which means for all real numbers, because of the unit circle, how it goes around and around and around in both directions, forever and ever, that means that we need to write it in a short, brief way so that we can write all our solutions, and so that it makes it easier to write it, because if we had to write every single one, it would take us till infinity, because there's infinite number of answers. So for each of these, we first want to find the one that's in between 0 and 2 pi, and then from there we can tack on our abbreviation. So if I have tangent x equals -1 over square root of 3, now you can think of it as it being an inverse to find the first one. Sorry about that. So tangent of x equals -1 over square root of 3. So as I was saying, you can think of this as like an inverse to start with. So if you were thinking for the first one, what angle gives you the value of -1 over square root of 3, so then that would be in the fourth quadrant. Now it's either going to be negative pi over 6 or negative pi over 3. So here, if I was looking for that, try one, see if it works. So we'll try negative pi over 6, so that's square root of 3 over 2, comma 1, or negative 1/2. So remember, tangent's the y over the x. So if I flip it, 2's cancel out, that multiplies across and gives me -1 over square root of 3. So then that would be my first angle, but like I was saying, you want to kind of think of it as in between 0 and 2 pi. But technically with overall reals, it doesn't matter if it's in between 0 and 2 pi, because negative pi over 6 is exactly the same as what if I add 2 pi to this, which gets me 11 pi over 6. Okay. Now the other angle that would work is on the opposite side in the third quadrant, or sorry, on the opposite side in the second quadrant, I should say. So a pi away, because pi is or tangent's reflection over the y equals x line, or over the origin. So the other angle that would give you the same thing would be 7 pi over 6. Now, because we're not really thinking about tangents, okay, or the inverse tangent of this, that's why I can do stuff that's not in the restricted domain for inverses, because I'm looking for all solutions. Okay, so 7 pi over 6 and 11 pi over 6 give me those answers. So if I wanted to talk about all reals, then both of these would be correct answers. But here, now you want to be able to show all the other solutions, so we need to tack on something that's called 2 pi times k. K represents an integer. Okay, all integers. We kind of did this with our domain and range for tangent and cotangent when we were graphing trig functions. So the 2 pi comes in because they're all coterminal angles to one another, so you want to tack that on at the end. Now, the interesting thing with this is because of the symmetry that it happens, 7 pi over 6 and 11 pi over 6 are actually the same angles, is if you add just pi to everything. So I can get both of these answers for my x all wrapped up into one neat angle because I changed what we're going like around. So if we only go around every pi, then I can hit 7 pi over 6 and 11 pi over 6 and all their other solutions or coterminal angles because of that. Okay. Cosine of x when it's equal to pi or 0.87. Here I need to do the same thing, but since it's a decimal, I'll have to plug it into the calculator. So doing the inverse first of 0.87 gives me 0.516, let's say. Okay, so here, if I'm looking at all the solutions, remember this is also plus 2 pi k. Okay, so that's one solution. Now, using our reference angles, I can get all the other ones. This one's in the first quadrant, so it's already a reference angle. So to get the other one, it's going to be in the fourth quadrant because that's the other place that cosine is positive. Okay, so then I need to take 2 pi minus this 0.516. So it gives me 5.77. Okay, and then add 2 pi k here. Now this one doesn't work like the last one where you can add pi, because adding pi to 0.516 would not get me to 5.77. So I have to show both solutions to be correct. So example 2, you're doing the same thing, except you need to do a little bit more solving. But here we're just looking at the answers in between 0 and 2 pi, not all reals. Okay, so first I need to add square root of 3. Okay, and then divide by 2. Okay. Now because some of these are on the unit circle, you don't have to do any extra math. So if I think about what angles give me square root of 3 over 2 for cosine, your values would be pi over 6, and then also 11 pi over 6. Okay. Now those would be the only solutions in between 0 and 2 pi, so those would be my only answers. So for letter B, when we have tangent squared x equals 3, before I can solve or figure out what this is, because this is not really on the unit circle, but if I take the square root of both sides, it gives me tangent of x. Now here, this gives me plus or minus square root of 3. Okay, so that gives me 4 possible values, because square root of 3 has 2 possible values on the unit circle, and then the negative square root of 3 gives me 2 possible values. So I need to explore both answers. So looking at the unit circle, now it's all going to be combinations that give you the same ratio, because you're still taking y divided by x. So let's start with the first quadrant, and then it'll be easier to find the rest. So I believe if we go back to the last example, using our prior knowledge, here we had negative square root 1 over square root of 3, and that was at negative pi over 6. Okay, so let's try pi over 3 first this time. So that point is 1/2 comma square root of 3 over 2. So for that one, if I'm dividing square root of 3 over 2 over 1/2, I'm multiplying by the reciprocal. That gives me square root of 3. Okay, so I'm looking for that ratio everywhere. So pi over 3 is one answer. Another place would be at 2 pi over 3. But that will be where it's negative square root of 3, because your x value is negative at that point, because it's negative 1/2. And then if I go down 4 pi over 3, that's where your both values will be negative. And then at 5 pi over 3, will also be 1 because y will be only negative, but cosine or x will be positive, so it'll give you a negative square root of 3. Okay, so here those are all the values that give you the ratio of square root of 3 plus or minus for tangent. Now for our last example, I have 2 where we're going to solve overall reals, but here there's a little bit more algebra involved. So here I have 6 sine squared of x minus 5 sine x minus 4. So here I need to do a little bit of factoring. So if you think about it as something that looks like this, it makes it easier to think about factoring. So if I was to factor this one, then I need to find plus or minus, because it's minus minus, and then factors of 6 and factors of 4 that give me negative 5. So in this case, now I just did the quick factoring for time's sake, but I came up with 2x plus 1 times 3x minus 4 for that factoring, because the 2x times 3x would give me 6x squared, and then the 2x and the negative 4 will give me negative 8x, and then 1 times 3 would give me 3x. So then that together would give me negative 5x, and then 1 times negative 4 would give me negative 4. So it works. So using that same factoring for our trig equation, so then I have 2 sine is going to be our x in this case, plus 1, and then 3 sine minus 4. So now here, using your zero product property, you can split them up, just like what we would do with the other one. And I would solve each individually. Okay, now for this case, I can't have a 4/3 because that's greater than 1, so this means it's no solution. So I only need to look at the other one where x is, or sine is negative 1/2 for an angle. So for this one, that would be in the 3rd and the 4th quadrant. So that would give me the values of 7 pi over 6 and 11 pi over 6. Now here, for both of those, I should write them correctly. Since we're talking about overall reals, I need to have my 2 pi plus 2 pi k for each. These are not directly across from each other, so I cannot write them as one singular thing, like we did before. Okay, so, thinking about that, correction, that means that this one was wrong, so that one should be 5 pi over 6, sorry about that. Same thing there. Okay. And that would be it. Okay, have fun.